Hey guys, today I'm going to teach you how to solve multi-step equations. By the end of this lesson, you'll be able to combine like terms, then isolate the variable to solve an equation. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. Quickly review what combining like terms means because it'll be important to today's lesson. So combining like terms just means basically the same things go with other same things. So that's what like means. It means same. So here we have nuggets and nuggets. This is nuggets and there's 12 of them. It's a 12 pack of nuggets. This is a 12 pack of nuggets. You can combine those. Now you have two 12 pack of nuggets, but you can't combine that with this regular $5 because dollars don't go with nuggets. So in math words, adding like terms have the same base and the same exponent and they can be combined. For example, x squared plus x squared is 2x squareds. Can't add x squareds plus x cubes because they don't have the same exponent. So even though they're the same base, they do not have the same exponent, so I can't add them. It's a quick review of adding and subtracting like terms. Please make sure that if you don't understand this, you go back and figure out how to do this with the expressions video. Coming to today's notes. Today we're going to see multi-step equations. That means there's more than just one step being done with the x or two steps being done with the x. You won't see problems like 2x plus 1 equals 11. Instead, today, you see problems like x plus 1 equals 11. And it's the same problem, but you just see it broken down into x plus x. We're going to actually combine our like terms first, then isolate the variable. So those are our steps to solve. We will combine our like terms, and then we'll isolate the variable to solve the equation like normal. So let's go ahead and look at this with an example. I always like to put a real world example here so you understand what like this is rooted in. So this is an example where Calvin goes shopping over the weekend, buys a new pair of shoes. So here's his shoes. He buys a t-shirt, a pair of sunglasses, and a hat that costs $9. So if the hat costs $9, we'll go ahead and label that out. So the hat is $9. It says that the shoes are twice as much as the shirt, okay? And the sunglasses are half as much as the shirt, okay? We don't know how much the shirt is. So I'm going to put in the variable S for shirt since we don't know how much the shirt is. But we know the shoes are 2 times as much as the shirt, or 2S. And we know that the sunglasses are half as much as the shirt, half S. And if you notice, I put little lines through my S's just so you don't confuse those for fives. Continue reading the problem. It says the total cost is $65. So this whole thing together costs 65 bucks. That goes on the other side of the equal sign. Reading that word problem, I wrote an equation to represent the purchase using S for the total cost of the shirt. Part B says simplify the equation by combining like terms. So we looked at those with expressions, combining like terms in an expression. But what I want you to think about this as is imagine that you got your line on the equals. I want you to just look on the left-hand side of the equation here. You have S's you can combine. You have 2S and 1S, that makes 3 S's, and then 1/2 S makes 3.5 S's. So you can simplify the equation by rewriting it as 3.5S plus the 9 equals 65. It's the same equation, but now I've just combined my like terms. That's the multi-step part because now you have a regular two-step equations, so we can solve the equation like normal. I always want to draw my line on the equals and then go in reverse PEMDAS. I want to add and subtract first. So I'm going to get rid of that plus 9 with a minus 9. The rules of equations are if I do it to the left side, I have to do it to the right side. So I do 65 minus 9, and I got 56. So 56 equals 3.5S. And now I want to do the opposite of the times S, or the times 3.5. So the opposite of times is to divide. My goal is to get the S by itself on the left side of the equation. So I need to divide by 3.5 to get rid of that. So if I do it to the left, I do it to the right. And I get a final answer of S equals 16. So S was the shirt in the example. So the shirt is going to be 16. And then it says, what's the cost of all these items? So the sunglasses were half of S, or half of the shirt. So that would be 8. And the shoes were 2 times the shirt. So that would be 32. So when you're solving an equation, just remember that you're looking for the missing variable. So it's like you're doing a puzzle, and you want to start putting puzzle pieces together if you can. So like on this one, we combined our like terms, then we isolated the variable. So your instructions are here. We're going to do the same process for all these practice problems below. So now let's look at it here. I'm going to start by rewriting the equation to give myself some more room. I have 4x plus 14 plus 4x equals 38. I also suggest that whenever you're writing this equation out, you do it on your own separate sheet of paper. It should be lined, and you should do one step at a time on each line. I also want to encourage you to press pause on the video, try it yourself, and then press play and check one step at a time. Then pause the video again, try it yourself, and press play when you're ready to check. So go ahead and pause now and try it all by yourself. What's the very first step going to be when I solve this equation? Well, the first step should be easy. Always draw your line on the equals. This easy step just separates my equation so I know that the left side and the right side need to be balanced and equal. I know that I need to get my x's on one side and my numbers on the other. So I'm just going to pick a side. I'm going to just write a little note in the corner. I want my x's here on the left because that's the side that they're already on. I want my numbers all together on the right side of the equation. So that just helps me organize this so I know I'm getting my x's all together over here and my numbers together over here. If you look at just the left side of your equation, I can cover up the 38 and just look at the left side of my equation. So you can literally just use your hand and cover up the right side of your equation just looking at the left. So I have a 4x and another 4x. They're being added together and they're like terms. I have like terms, which means they're the same variable base, which is x, and the same exponent, which would be 1 for these. I can combine them. So I can combine 4x and 4x to be 8x. And at this part of the equation, I know a lot of people ask, hold on, if you're adding 4x's together here, don't you have to do the same thing to the right side of the equation? The answer for this one would be no. They're already being added together on the left side. All I did was write them together. So I didn't actually add an extra anything. It's already being added over here. All I did was made it simpler and combine my like terms. The reason I want to do that is because now it's an easy two-step equation. So now I'm going to go ahead and try to get rid of the plus 14. So I get rid of a plus 14 by using an inverse operation. The opposite of plus is minus, and I want to cancel out a positive 14. So I cancel that out. If I do that to the left side, I'm going to have to do that to the right side. So I'm going to do 38 minus 14, which gives me 24. So all that's left on the left side of my equation now is 8x. Remember, this is my x side, so I'm trying to get the x all by itself. So I need to do the opposite of what's being done here to get rid of this 8. I need to get rid of this 8. It's 8 and an x next to each other, which means times. So I need to get rid of it. Times 8. The opposite of times is to divide. So I'm going to divide by 8. If I do it to the left, I have to do it to the right. So 8 divided by 8 is 1, so it cancels. So now I have an x equals 24 divided by 8, which is 3. So x should equal 3. The very last step you should do is to plug in 3 back into the original equation here, just to double check that you end up with 38. If you plug in 3 for the x's here in this equation, you should end up with 38. We're going to look at number 3 the exact same way. It's just a little more confusing because you see negatives and minuses. So I understand if this one's a little bit harder, but I want you to try this. So go ahead and pause the video now and see if you can figure out what the very first two steps are going to be. Press play when you're ready to check. Okay, so you should have just looked at this problem and realized the first thing you want to do is draw your line on the equals. And then the second thing that you can do is realize this is my x side, this is my number side. So I'm going to separate my equation and decide which side my x's are going to be on. They're already on the right, so they're going to have to stay on the right. And I want my numbers all together alone on the left. Now we want to look at this and realize that we can actually combine some like terms. So if I just look at the right side of the equation, I have 10 x's and I have negative 40 x's. So I'm going to actually rewrite this as a plus negative 40 because I know that minus 40 is the same thing as negative 40. That's helpful because if you take 10 minus 40, you're going to end up with negative 30. So you actually have negative 30 x's here on the right side of your equation. All I did was I combined the 10 x's and the negative 40 x's. So step 1 for this is going to be to see if I can combine any like terms, and I could. On the left side of my equation, I still just have a negative 15. I didn't add anything extra to this side. I didn't do anything, so I don't need to do anything right now to the left. So all I've done is just rewritten my line. Now what I want to do is see if I can figure out what I can do to get x by itself. I'm trying to get my x's alone on this side, so I need to move this times negative 30. See if you can figure out how to get rid of a times negative 30. Try it, pause the video, and press play when you're ready to check. So a mistake I see a lot of people do on problems like this is that they will add 30 here. This is a mistake. That's a mistake because it's not asking you to minus 30. It's saying it's negative 30 times x. It's a number next to a letter. That means times. So you need to do the opposite of times negative 30, which is divide by negative 30. You always do the inverse operation and then just do it by that number. So if I do it to the right side to cancel, I need to do it to the left side. So negative 15 divided by 30, negative 30, is a negative divided by a negative, which will be a positive, and then 15 divided by 30 is 1/2. So 1/2 equals x. Write this as 1/2 equals x, or x equals 1/2. You always want to double check and just plug in 1/2 back into the original equation. If you put in 1/2 for the x here, minus 40 times 1/2, you'll end up with negative 15. So the next 5 problems I want you to practice on your own. I'm just going to go over number 6 in this video. We can go over the rest together if you need help with them. So I'm just going to go ahead and give you a second to pause the video, try number 6 at least by yourself, or try all 5 of these, and then press play when you're ready to check just number 6. All right, so make sure you have enough room on your paper to solve this out on. You want to go ahead and write this equation out, and then you want to draw your line on the equals and realize you want your w's on one side and your numbers all alone on the other. So just make a note of that. That always helps me. And then what I'm going to do for you is I'm going to think about this with a real world example. So this is like saying I have dollars and I have waffles. Before I bring in the real world example, it'll help you and me both to understand this instead of minuses as plus negative. So anytime I see a minus, I always change it to a plus negative. So let's go ahead and start with the waffles. I have waffles for W. So what I'm going to do is I'm going to think about this as I have negative 5 waffles and 7 waffles. I have 7 waffles, and it says take away 5 of those waffles before I do anything else. I have 5 waffles that are going to get eaten from the 7. Go 1, 2, 3, 4, 5 waffles eaten. So that's my waffles taken care of. I had 7, and I took away 5. So I've already simplified 7W minus 5W is just 2 waffles left, or 2W. Now let's look at the 18 and the negative 4. This is like saying I've got $18, and then I add a negative $4, or I take away $4. So if I have 18 minus 4, or 18 plus negative 4, that's the same thing as saying 14. So I have 2 waffles plus $14. That's all going to equal to 28. So notice I didn't do anything to the 28 yet. All I did was simplify what I could on the left side of the equation first. And instead of thinking about this as combining like terms, I just thought about it with waffles. Waffles and money. So that's just one easy way to think about this. Combine like terms means just do what you can do. If you can put W's together, put your W's together. You know numbers go with numbers, so just put your numbers together. This helps because this right here is a simpler equation than it would be to have 18 plus negative 5W plus 7W plus negative 4. It's too much to do. So simplify what you can first, then solve. Now that I've got it written like this and I still have my line on the equals, now I can start solving my equation. So I'm going to take the opposite of a plus 14, which is a minus 14. If I do it to one side, I'm going to do it to the other. So those cancel. And I know that 28 minus 14 is still 14. So 2W is left on the left side. So 2 times a number equals 14. So 2 times the number equals 14. The way to figure that out if you don't know already is to do the opposite of times, which is divide. So you divide by that number to cancel. So 2 divided by 2 is 1 W left, and then 14 divided by 2 is 7. So my final answer would be W equals 7. So like one waffle would be worth $7. I'm going to plug that in to check. Some people ask me, do you want to plug it in here, or do you want to plug it in here and here? You can plug it in into the original equation. You can also plug it into this step. I would plug it into the original equation for sure. And if you plug it in, you should end up with 28. So here's the answers to these 5 problems, just in case you wanted to check those. Like I said, I was just going to do number 6 with you in this video. And then if you have any questions on how to do 4, 5, 7, or 8, you can work with me in class. All right, guys, that's it. If you made it to the end of this video, please put in the comments whether you prefer waffles or pancakes. Today we learned how to solve multi-step equations. So now you should be able to combine like terms, then isolate the variable to solve an equation. So now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.